So the final version we're going to consider is going to add assertions that should be true specific to the withdrawal method rather than the class invariants which should be true at the end of every method. So you should really distinguish between class invariants versus postcondition. Think about class invariants being a very special postcondition. Think about the class invariant being the postcondition for every method. But not vice versa. Okay. Let's talk about postcondition, and then we will define that. So now we're going to improve version number 4 by adding postcondition. What's really postcondition? It's it will be the precise conditions which you will satisfy by a method upon its completion. So that's why postcondition should be checked at the end of the method execution. Precondition should be checked in the pre-states, and postcondition and invariant should be checked in the post-states, right? Remember, we talk about terminology, pre-states and also post-states. So this relies on the assumption that right before the method starts, the preconditions are satisfied. So we assume that the client's obligations are satisfied so that we can now, after execute the method implementation, the postcondition and invariant should be satisfied. So that's the once the client's obligation preconditions are satisfied, now the supplier's obligation, which will be postcondition and class invariant, they should be satisfied after the method finish its execution. Okay. Let's do a little bit exercise over here. So let's revisit our divide method here. We talked previously the precondition should be that y is not equal to 0. That's a surface condition. Assuming that y is actually not equal to 0. So we can go ahead and execute the implementation for divide. So now, what should be the postcondition? You can think about the postcondition is really try to relate. Let's say for this particular example, you can see we do have a return type. So in IFO terminology, it's called a query or accessor, right? For a query that's going to return a result, a return value, the postcondition typically should relate the return value with the input value here. So somehow we should really relate x and y being the input with the return value. In the case of IFO, every query has a reserved keyword called result. You actually pick it up from the tutorial video for week number 1. So now what should be the relationship between the return value from divide and x and y? Okay, pause the video please and then think about it before you resume. Okay, so this is the answer. So the return value from the divide, whatever it is, times y should be x. So now we assume that it divides perfectly. Okay, so now for example, 6 divided by 2 should be equal to 3. So 3 times 2 should be equal to 6, right? That's the postcondition. So this is a special case where we are doing a very easy postcondition for query or accessor. Whenever you want to do postcondition for a query, always relate the return value, which is result, in your postcondition. Okay. So what about the postcondition for binary search? And the binary search is going to return the result of type Boolean. So it's either be the element x is in the array xs or it's not in the array xs, either true or false. So now, what should be the relationship between the result and x and xs? This one is slightly trickier. You can either think about some case analysis. So what happens if x is not found in xs? And what happens if x is really found in the array? So it's either case 1 or case 2. Okay, but you gotta think about what kind of operator you can use from your 1090. Okay, pause the video and think about it. Okay, the answer should be like this. First of all, result is actually a Boolean value, either true or false. With the result, if and only if x is a member of xs, so we are treating just xs like a set. If x is actually in a member of the array, so that means result should be true, and vice versa. That's why it's an if and only if relation here. So that's why I said in the beginning of the lecture here, in this course, in order to make the contracts precise and also unambiguous, we have to use mathematical rigor. Which is why 1090 is actually a prerequisite for this particular course. So I would suggest there will be some references later to suggest, but you should really try to pick up the basic techniques about understanding of predicates, relations, sets, and etc. For this course. Okay, so how do we check the postcondition? Well, apparently we want to check it at the end of the method call, just like the class invariant. So exceptions is not the way to go again. So the best we can do is by using assertions. And again, because it's an assertion, so when you generate a Java API, the assertions will not appear in the API for the method. So that's one drawback. So it's not public. The reason that you want to make a contract is because you want to make it public. So both the supplier and the clients can agree on. So the fact that assertions are being private is not very useful as a contract, even though it will do some runtime checks for you, but it's still not very useful. Okay, so now we're going to create version number 5, and then we're going to add that method specific postcondition to really illustrate. Okay, so now I'm just going to switch to iPad and show you exactly what you should really pay attention to for this final version here. Let me just, okay, so now we are in version number 5 over here, and then we talk about the withdrawal method. Okay, so this is our previous precondition check or exception check, and also there's another exception check, and this guy over here is the implementation. Of course, this is the correct version, but we're going to see what happens if we got an incorrect version. So you can, this is the implementation, and these two are approximately the precondition, right? These two. And then we also have the class invariance over here. So this guy here. So this is our invariance for the class, right? That's what we learned from the previous version. So what's really new is this guy here. This is something that's new. Okay? So now how do we understand this? The key idea is really about a postcondition relates between pre-state value and the post-state value. So this, what I'm saying here, formally is written on the slides, but I want to give you some intuition here. Imagine that at a runtime, when we are trying to use the withdrawal method, so let's say we already got ACC being of type account v5, right? So let's say we got ACC dot withdraw. And then some value over here. Okay, the value doesn't really matter. Actually, you know what? Let me just maybe make it more obvious to you. Let's say withdraw $20. Okay, we want to withdraw 20. So how do we understand the postcondition? Again, let's first put the pre-state and post-state into the context, which we learned from the previous lecture. Immediately before the method is executed is called pre-states. And immediately after the method is executed, it's called post-states. Sometimes we say pre-execution, and sometimes we say post-execution, but pre-state, post-state, you should really understand what I mean. So now in the pre-states, let's say this. In the pre-state, we have to understand what the attribute value is. For example, ACC.balance before the execution. So let's say, for example, let's say it's simply 100 before the withdrawal. And then we want to say whatever post-state value is, ACC.balance. Now, notice one thing here. We are talking about the same balance attributes. However, we are talking about the same attribute value in two different states. One is the balance in the pre-states. Before, presumably, it will get decremented by the amount. And we talk about another balance value over here after, presumably, it has got decremented. So we intend to really see, the postcondition is really try to relate these two values in two different states and to see what the relationship should be between them. So what should it be? This newer value over here after decrements should be less than this older value that's actually before the decrements, but more precisely. So what we can write is this. So postcondition is actually going to be checked in the post states, right? Right after the method is executed. So post states is where we check the postcondition. And what should it be? So now it should be ACC dot balance is equal to, okay, so here when I say equal, I mean mathematical equality. I don't mean assignments. Okay, just to avoid confusion, but I'll just say equal. It should be the same value as, so now we want to refer to this particular pre-state value. So let me just use a different color, okay? So I want to say ACC dot balance over here. And what should it be? It should be minus whatever amount I want to really do the withdrawal, right? So now it should be minus 20. So now here's the trouble. Here, conceptually, you can simply see I'm trying to use the color. One is green for pre-states, and one is red or pink for post-states. And I'm trying to draw the relationship between them, which should be minus 20 and using equality here, right? But that's conceptually, we roughly understand what we are doing. But to really encode this post-condition here, we have to somehow memorize the pre-state value over here into some temporary variable, so that we can use that temporary variable in place of this guy over here. Okay, so now let's say this, and then I'm gonna once we understand this conceptually and how to encode it, the Java code will make much more sense. Let's say this. Let's say for this particular value over here, we're going to save that into a variable called old balance. So old balance is simply just going to be a temporary variable that we're going to refer to. And the old balance is simply assigned to the initial balance over here in the pre-state, so that'll be 100. And now, after executing this withdrawal method here, let's say the implementation was correct. So now, ACC.balance will now be decremented from 100 by 20, so that should be 80. So now, in order to really compare the pre-state and post-state, which two variables should we compare? We should really compare ACC.balance as is, which is 80, and also the old balance, which in some way caches the value. So I'm going to use the value word here, caches, which means it memorizes the value, so that when you actually modify the attributes in the implementation of the method, we can still use this cache version of the value in the pre-state, so we can always compare the same attributes, but in the between the pre-state and the post-states. So now ACC. So here, rather than saying this, we're gonna say old balance. Okay, so let's now just be complete. So now, what should be the old balance? Old balance is, after that, old balance is simply 100. 100, so 100 minus 20 over here, and what's the current value for ACC.balance? It should be 80. So what we have to solve is this equation. 80 equals 100 minus 20. Of course, it's going to be true. Okay, that's kind of the idea for encoding this post-condition. It's kind of conceptually, it's not too hard, but it's very inconvenient. That means it depends on how complicated your post-condition is. If your post-condition involves many variables back in the pre-states, then for every pre-state value, you have to so-called cache them over here. Okay, let me just show you how it works quickly. Okay, so now once we understand this idea over here, so now hopefully everything will be straightforward. You can see this particular line here is to cache the value of the pre-states. Let me just make it clear to you. So this line over here caches balance in the pre-states, so that when we actually try to do this particular implementation over here, either right or wrong, okay, so this implementation does not affect the cached version of balance. Okay, this is really important, and I would like you to understand the intuition, because later on we're going to talk about exactly what we meant by doesn't affect, because when the variable gets more complicated, especially reference type, and when you have aliasing as in OOP, you have to be careful when you do such post-condition. So does not affect the cache version of the balance. This is really important, okay? And then when we actually caches the pre-state value, that's also important. So now we can use it, the O balance from the pre-states. Okay, so now when we do this assertion here, so this will be the post-state value. Okay, let me just annotate very quickly. So this is the post-state value. And this is the pre-state value that's cached. And then we simply try to state the relation between the using equality and also subtraction. Okay, hopefully that makes sense to you. And now I would like to just show you one more thing. With this particular postcondition encoded, have we solved the issue from the previous version? The answer should be yes, but let's see how exactly it's solved. Okay, so now again we put the clients and supplier together. So now let's say this. For the client class, we have account V5 Jeremy. Okay, initial balance is simply just 100. Okay, that's the initial balance. And over here, this is where the client supplier relationship shows. So now supplier object is Jeremy, withdraw $50. And let's now consider the case where withdrawal is implemented wrongly. That's actually what we wanted to resolve from the previous version. Let's see exactly how adding the postcondition, how this can help by adding the postcondition. So now we want to withdraw $50. So now this amount over here would be 50. And don't forget, the current balance in the pre-states is actually 100, right? That's how we start with. So now the balance in the pre-states is 100. That's how we start with. And now for this particular line over here, we're going to cache the value for O balance, right? So this balance over here is exactly the pre-state value, which is 100. So O balance over here is 100. And that wouldn't be affected by the actual implementation. And we're going to bypass the error checking because the input value is actually positive and also is affordable. So now we're going to execute the implementation over here. So this is actually actually I made a slight typo here. I really meant to put the wrong version of the implementation. Okay, let's see this. Let's say for the withdrawal, rather than decrementing, we're going to increments, let's say. Okay, that's really what I meant to put. Okay, let's say there's a wrong implementation. And the wrong implementation is going to add. This balance currently is actually 100, right? 100, and also the amount that we want to add is 50. So it's going to set the balance to be 150. And now you should think of this value over here as the post-state value. Okay, so now let's check the post condition. When we want to check this particular post condition over here, let's see exactly how that can be done. Okay, let me just draw a little bit better for you. Okay, so now how we check it? This balance over here is the current value, which is post-state value. I'll say post-states. Okay, that should be 150. Okay, so we got 150 on the left hand side of the equality over here, and then the O balance over here is the cached pre-state value, right? Pre-state value over here, and that one there is 100. So we got 100 over here minus the amount, which is 50. So now we got 100 equals 50, and apparently this equality here will be false. So that's why this particular assertion will give you some assertion error. That's more like a conceptually post-condition violation. So that's why here you will see assertion error. Post-condition should be balance deducted, right? Again, there was a slight typo here. It should be a plus over here. So when you study the notes, please be careful. Okay, I really try to go very detailed with this particular simple postcondition here, just to get you the idea. So in order to implement the postcondition, you have to worry about the relationship between the pre-state value and the post-state value. And specifically to really check the pre-state value at the end of your method implementation, you must memorize or cache the value before the implementation is executed. Okay, that's something I would like you to keep in mind. Okay, let me return to the slides. Everything has been said. That's exactly the version I presented. And then the only thing is, well, with the typo. So you really should imagine that this is a faulty implementation. So this should be plus. Okay. Okay. So now the postcondition error really good, because now when the implementation is actually faulty, we can actually give some assertion error for postcondition violation. So there's at least one party to blame. In this case, the supplier implements the thing wrongly, so they should be blamed.